Great, here's a nice curve sketching problem given the derivative function f prime. What are the critical values of f? Well, the critical values of f occur where f prime is equal to 0 or is undefined, but it doesn't look like that happens in this case. So f prime equals 0 where x equals -2, 0, 2, and 4. So then over what intervals is f increasing? Well, and we need to justify. So f increases on the intervals, and we need to check where f prime is positive. So here and here. So I have -2 to 0 union 4 to infinity. And my reasoning is because f prime is greater than 0. Now my next question is, for what x values does f have relative extrema? Identify each as a relative min or max. So we're going to have maximum values where f prime goes from positive to negative. And that happens at x equals 0. I believe that's the only one where f prime goes from positive to negative. Now we're going to have relative minima where f prime goes from negative to positive, and that's going to be at x equals -2 and at 4, so right here and right here. Over what intervals is f concave down? Well, f is concave down where f prime decreases. So that is going to be on the intervals, let's see here, erase that, we need the intervals -1 to 1, 2 to 3, 5 to infinity. So -1 to 1 union 2 to 3 union 5 to infinity. Now for what x values does f have a point of inflection? So f has a POI, point of inflection, where f prime has turning points. So those turning points occur where x is equal to -1, 1, 2, 3, and 5. Now they want us with a red pencil to sketch the function f, assuming that f of 0 is 0. This is going to be tricky. So we know that f is decreasing all along in here, okay? So I'm going to work to the right first, and then I'll go backwards. So from 0 to 4, my function is decreasing, although it has a stationary point at 2. Function is decreasing, therefore the derivative is decreasing, so my function starts concave down, switches to concave up, has a temporary point here, switches to concave down. What I mean by a temporary point is a horizontal tangent line right there at 2, goes concave down again, switches to concave up again. All this while, the function is decreasing, but I've got changes in concavity at 1, at 2, and at 3. Then, starting at 4, my function is increasing. So my function is going to be increasing and concave up until 5, and then increasing and concave down thereon into infinity, and I want my slope to go towards 0. Now working backwards, my function must have been increasing from -2 to 0, and actually decreasing from -infinity to -2. Concave up from -infinity to -1. So I have a decreasing function, then an increasing function, all the while concave up, and then I am still increasing, but now concave down. So that is a pretty good graph of f. So now they want, in blue, they want us to sketch the derivative of f prime, which is the second derivative. And I'll see if I can put them all on the same grid here. So where the function increases, my derivative of f prime will be positive. I need positive, then negative for a whole long, wait, I need positive, then negative, then positive, then negative, then positive, then negative. I've got a whole lot of changes in sign on F double prime. And I'm going to be honest, I need to get rid of my red graph in order to do this correctly in blue because it's confusing me. So here we go. I'm going to graph the derivative. I want to look at points where concavity changes and where there are horizontal tangent lines. So let's do the horizontal tangent lines first. These are zeros of my second derivative function right there. And then I'm going to point out in green where I have inflection points on my derivative function. I'm guessing where these are, by the way. Okay, those are going to be turning points on the second derivative in blue. So now I need an increasing function, so its derivative is positive, but the function is concave down, so the derivative is decreasing. Okay, now the next segment, my derivative is negative and decreasing because the function is decreasing and concave down. So I'm to here now, and this is supposed to be a nice smooth curve. Smooth it out there. My next segment, the function is decreasing, so its derivative will be negative, and the function is concave up, so its derivative increases, which makes sense because it has to go back to that zero. I've got a tiny little section here. My derivative will be positive because the function's increasing, and my derivative will be increasing because the function's concave up. Then I have a change in concavity, so I have a turning point there to get back to the zero. This little section, once again, the function is decreasing and concave down, so the derivative is negative and decreasing. Then this little section here, the function is decreasing and concave up, so its derivative will be negative but increasing. The next segment, the derivative will be positive because the function is increasing, and the derivative will increase because the function is concave up, till I get to some sort of turning point here on the derivative function because of the inflection point on the regular function, which in this case is f prime. This section here, my function is increasing and concave down, so my derivative is positive but decreasing. And then last, oh, no, not last, this little section, the function is decreasing and concave down, so the derivative is negative and decreasing. And then last, function is decreasing and concave up, so my derivative is negative and increasing, and just make sure that you're increasing towards zero. That was tricky, probably more tricky than anything you'll have to do, yay.